Hi everyone, welcome back. I'm Nisha. Today we are going to study about dynamic memory allocation in C++. I already uploaded one video based on pointers. That link is in the description box. If any doubt, please click and view it. So let's see what is dynamic memory allocation. Dynamic memory allocation in C++. See, these are the important points to remember. So the first point is memory is allocated during the execution of the program. This is the first point and the important point. So the memory will be allocated at the time, at the execution time or at the using time, at the run time of the program. But in static memory allocation, the memory will be allocated at the compilation time, not on execution time. See the second point. We are free to allocate and deallocate memory whenever we need and whenever we don't need anymore. What is the meaning? The memory we can be freely allocated at any time we need it. And the same time we can deallocate the memory also if you don't want that space. That is the speciality of dynamic memory allocation. But in static, we can't deallocate the memory. That is the duty of operating system. So here the programmer can decide when they want to deallocate it. Clear? See the third point. Data type could be any built-in data type including array or any user-defined data types including structures. The meaning is for the pointer we can set any data type. Pointer means it's normally a variable, right? So when you are declaring a variable we need to specify the data type. So any built-in data types like int, character, float, any predefined data types we can use for the pointer variable, and array also we can include it in it, and the user defined data type. User defined data type means through structure we can create user defined data types. That also we can use through pointers. So these are we already studied in the last video. Okay, so let's see the dynamic operators. What are the operators using for dynamic memory allocation? See, there are two operators. The first one is new and the second one is delete. The operator new is a keyword in C++ and it triggers the allocation of memory during runtime or the execution time. So this operator is a keyword using for allocation of memory at the time of execution. Then this next point is it's a unary operator. Unary operator means one operator and one operand. So this is a unary operator. And the required operand is either a fundamental or user defined data type. So here through the new operator we can use one more operand there. That operand is a fundamental data type or a user defined data type. Then the next point is the size of this location will be the same as that of the data type used as the operand. Through new, which data type we are specifying, that data type only we can put for the pointer also. So that space we'll get in the memory. See the point once more. The size of this location. What is the size of the location? Location will be the same as that of the data type used as the operand. The same as the data type what we put for that operand near that new keyword. Understood? So see the syntax. Pointer variable is equal to new space data type. So what data type we specified here, that much space we will get it in the memory. So through pointer we can allocate this memory. This is the way of memory allocation in dynamic memory method. Clear? So once more, new and delete are the two operators using for this. Through new we can allocate memory at the execution time. through which statement? This is the statement using for this. So which is the pointer variable, that is equal to new space and the data type. So through this pointer we'll get a memory allocation, and we can point to this with this pointer variable. And this one is a unary operator, and the required operand is either fundamental or derived or user defined data type. And the size of this location will be same as that of the data type. Clear? Now see the important point. Pointer variable is used to hold the address returned by the new operator. What is the meaning? This pointer variable is used to hold the address returned by the new operator. When we are using this new operator, we will get a memory space there. That memory space have an address, is it? So that memory address will pointed by pointer variable. So that is the content of the pointer variable now. Clear? So see, pointer variable is used to hold the address returned by the new operator. Pointer variable will hold the address of that new operator. Clear? Now we can check some examples here. See, short asterisk sign PTR. So this means PTR is a pointer variable and its data type is short. So the pointer can point only to the short data type. Then float star PTR1. So PTR1 is the pointer here and its data type is float. So this PTR1 can point to only one float data type. Same like one structure data type also put here. Struct complex. Complex is the user defined data type. And star PTR2. The meaning is PTR2 is the pointer variable and its data type is complex. So this PTR2 can point to that user defined data type complex. So see how we can create or allocate memory spaces through this pointer. PTR is equal to new short. The meaning is through PTR we are allocating a memory space. How much space is there? 2 bytes. See, new short. Short shows new bytes. See, PTR. This is the pointer variable. And see the value inside it? That is the base address of this. This is new short. So here we allocate, these are the memory spaces. So 2 bytes we took for PTR, this short type. Okay, so 2 bytes are there. So the base address of these 2 bytes are 1001. There is no name for this cell now. See, there is no name. When you are using PTR is equal to new short means we will get 2 bytes there, 2 bytes of memory allocation. But we are not specifying any name. So there is no name. So how we can access the values? Only through the pointer. See, so the pointer will hold the base address of this cell. Clear now? See, same like for the float PTR1, PTR1 is equal to new float. So PTR1 is here now, and for the float 4 bytes we will get. So 4 byte space we took for this float 1, and there is no name for this allocation, but PTR1 is holding the base address of this one. So through PTR1 only we can access the values of this. Clear? And see, for the complex, PTR2 is the pointer. We created blocks here. 4 blocks are there because in complex, in the later structure portion we already studied, 2 data members are there. One is real and the other one is imaginary. Both are showed data type. So here 4 bytes we took for this complex. And PTR2 is holding the base address. So through PTR2 we can access the values of this. So this is the way of creating our memory allocation in dynamic method. Clear now? See, first we want to declare the pointer variable. Then the next step is what? Through the pointer variable, we can create cells according to the data type by using the new operator. If it is short, new short. If it is float, new float. If it is complex, new complex. If it is int, new int. This is the way of creation. Clear? Okay. How to access the values? See the points? The dynamically allocated memory locations cannot be referred to by ordinary variables. See, there are no ordinary variables A, B, like that variable name is not there. Only address is there, is it? So through that address only we can refer that location. So that is the point here. The dynamically allocated memory locations cannot be referred to by ordinary variables. So how it is possible to access? See the points. Rather, these are accessed using indirection operator only. By using this operator only, we can access the values of that cell. There is no name for that cell. So how we can access? Through pointer only we can access. That also with star operator, asterisk operator. Its name is indirection operator. See the next point. Initialization is also possible in dynamically allocated memory locations. So if we are creating a cells by using new operator, we can initialize at that time also. So how? What are the syntax for this? See the syntax for initialization. Say first data type, then the star, then pointer variable name is equal to new, then the data type and in bracket value. So this value will assign in the block at the declaration time of a pointer variable. So this is the way of initialization. Initialization means value assigning at the time of declaration of a variable. So here also through pointer we are creating a cell with the initial value. Understood? Now the next one is assigning. Assigning means already cells are there. We created by using new operator. Now next, how we can assign values. Without a name, how we can assign values. So through pointer variable, we can assign the values. But by using which one? That asterisk sign. That is the point here. Accessed using indirection operator only. See, indirection operator, then the pointer variable is equal to value. So we are assigning the value to where? Not in the pointer variable. Where we are assigning? This pointer variable is pointing some other cells. Is it this one? Yeah, that without name one cell is there. So through this pointer variable, we can assign the values to that block. Then how to input the values? Same like cin, then asterisk sign is needed for the pointer variable. The meaning is the pointer variable is pointing to some other cells, so the input value will stored in that cell. That is the meaning of this one. So these are the syntax of initialization, assigning and input. Clear? See the examples. Int star ptr. It's a pointer variable and its data type is int, so it can hold the int data type. So equal to new int and in the bracket I put 0. The meaning is what? One blank cell is there and we initialize 0 inside that and the pointer is pointing to that cell. There is no name for that cell. And the next one is star ptr is equal to 314. The meaning is now we created one cell through the statement. So we are assigning a value. 0 will overwrite and we are assigned 314 to that cell. And in the next line, cin star ptr, the meaning is the same cell itself, we are assigning a new value. The user will give a new value. That value will assign to that cell. Clear? So this is the way of using or accessing the values through dynamic memory allocation. So we want to specify the pointer with asterisk sign. Then only we can access the values in the new block. Clear? Okay. So this shows how we can deallocate the memory. Once memory is allocated dynamically using new operator, it should be deallocated or released before exiting the program. So we want to deallocate that space before exiting the program. How we can deallocate? So C++ provides delete operator for this purpose. So through delete operator, we can deallocate the memory block we created by using new operator. See the important point? It is programmer's responsibility to deallocate dynamically allocated memory. But in static, the deallocation will be done by operating system, not by the programmers, because at the compilation time it will create, and by ending the program or when you are switching off the system, then only the memory will be deallocated. But if you are using a dynamic memory allocation method, the programmer can provide a statement for deletion. So what is the syntax? Delete is the operator, then space, then the pointer variable, and put semicolon there. So this is the way of deleting the cell created by using new operator. See the example? Delete si underscore ptr means we are deleting a pointer variable. So we are not putting star there. Okay, only to access the contents we want to specify the star there. So for deletion of a pointer variable means delete space ptr. That means the which cell we created by using ptr, so that cell will be deallocated. Same like delete ptr1, delete ptr2. So this is the way of deleting the cells created by new operator. Okay. You all understood the concept of dynamic memory allocation, how we can allocate a memory and how we can deallocate a memory, and the syntaxes. So in the next session, we can learn how to do the applications by using dynamic memory allocation. Okay, so now we can wind up. Thank you. Bye.